Hello everyone, welcome to yourfaculty.com. We are going to deal with some problems in volume and surface area. Hope you got chance to go through our video on formulas with respect to this chapter. And this is our website. Do like us on our Facebook page, Your Faculty. So let's move to our first question. If a solid sphere of radius 10 centimeter is molded into 8 spherical balls, solid balls of equal radius, then the radius of each ball is. So what they are saying is there's a bigger ball and it's being now converted into 8 smaller balls. So you have 8 small balls like this. The simple way to do this problem is just saying that volume of the solid sphere is equal to 8 into volume of the solid balls. Alright. So what is the volume of a sphere? We know the formula 4 by 3 pi r cube. I am making it as capital R because there is a large for this large sphere, and for the small one I'll put a small r, is equal to 8 into 4 by 3 pi r cube. So what do we do now? We just cancel both of them off. So we are now left with, we know that r cube is equal to 10. So this is 10 cube by, if you bring 8 below, it will become 2 cube equal to r cube, which is this r. So r is equal to 10 by 2 is equal to 5. So we are taking a cube root and we get 10 by 2 because this is also 10 cube, this is 2 cube, this is r cube. So we take a cube root and we get 10 by 2 and the answer is 5 centimeter. Easy, isn't it? So you just need to understand that this particular concept, that when a particular material is molded and converted into another material, the volumes are going to remain the same. And hence, we just need to equate them. If you get the shapes right, or if you understand the whole question, the answer is just application of the equation. Moving on to the next question. A cylindrical vessel of radius 4 centimeter contains water. So, there is a cylindrical vessel and it contains water. So, you can assume that the water along with the container also forms a cylinder. Okay, so this also looks like a cylinder only. This is the level of water. Fair enough. So this is the level of water, and a solid sphere of radius 3 centimeters lowered into the water until it is completely immersed. So I am putting a solid sphere into it of radius 3. What is the radius cylinder? 4 centimeter. This is 4 centimeter, this is 3 centimeter. So applying Archimedes principle, the volume displayed will be actually the weight of the sphere. So what happens is, which would mean the level of the water that it increases, it's also creating a cylinder over here. You see a cylinder over here. This volume and volume of the sphere is going to be same. So what should we do now? I'll call this as H dash. So volume of the cylinder, volume of the cylindrical shape formed by increase in water level is equal to volume of the sphere. So what I'm trying to say is, this particular cylinder, the volume of this cylinder is equal to volume of the sphere. Very simple. Then what is the next step? Pi r square, I'll keep it as volume of cylinder. So since it is cylindrical, I'll take RC, which is 4 centimeter here. Pi r square H dash, which is this H, equal to 4 by 3 pi, I'll keep it as RS pi r cube. So 4 by pi r square H is equal to 4 by 3 pi r cube. This is the radius. RS is equal to radius of this. So RC is equal to 4, RS is equal to 3. So what do we do now? We just cancel this off, and then this one is equal to, we'll just start substituting the values. 4 into 4 into h dash is equal to 4 by 3 into 3 into 3 into 3. This is 3 cube, right? So I cancel this, I cancel this. So h dash is equal to 9 by 4 centimeter. Move on to the next question. A metallic cone of radius 12 centimeter and height 24 centimeter is melted and made into spheres of radius 2 centimeter. How many spheres are there? Same question, right? Like how we did the first one. So I will not try to draw here. I will straight away write the answer as volume of cone is equal to something. I'll call that as x into the volume of sphere. Please note, x is equal to made into spheres. How many spheres are there? Number of spheres. Okay. So what is volume of cone? 1 by 3 pi r square h. And what is x into volume of sphere? 4 by 3 pi r cube. What is r here? Radius of the cone. And what is small r? Radius of the sphere. This is just for your understanding. You don't have to write in all these things in your exam. If you know why you are using these variables, you just need to equate it. So 1 by 3 into, you can cancel this pi by off. You can actually cancel this 3 also. So what is r square here? It is 12 into 12. And what is h? 24 is equal to x into 4 into, what is r cube? 2 into 2 into 2. So we now just need to cancel this. What do we do now? We'll start cancelling. You get 3. You have 4 3s are, and get 12. So x is equal to 12 into 9, which is 108. That's your answer. A metallic hemisphere is melted and recast in the shape of a cone with the same base radius r as that of the hemisphere. If h is the height of the cone, then again, so volume of hemisphere is equal to volume of cone. And here they even simplified our problem by saying that the radius is same. So we finally need to equate this, and we will get one of the expressions which is correct here. So if h is the height of the cone, then that's what they have asked. Now, what is the volume of hemisphere? Volume of sphere is 4 by 3. Volume of hemisphere is 2 by 3 pi r cube. I'm using the same variable as used in the question. And volume of cone, 1 by 3 pi r square h. H is what we need to find out. So what do we do now? We cancel this off, we cancel this out, we cancel this, and we are left with just the r. So h is equal to 2r. That's your answer. Thanks for watching our video. You can subscribe to more videos at Your Faculty channel. Like us on our Facebook page and our LinkedIn page, and you can also follow us on Twitter. Thank you.